Okay, in this video we're going to be working with isosceles and equilateral triangle. Let me refresh your mind what is an isosceles triangle. Isosceles triangle looks like this, and the definition of isosceles triangle is two of the sides are equal. Two sides are equal. So if I call this triangle ABC, A, B, C, two of these sides will be congruent. So this side we can rent to this one. Okay, it is definition of isosceles triangle. Now what you need to know is the following. You need to know what is the opposites. Okay. Now first let me do a refresher. The angles use capital letters. The sides we use lowercase letters. So one of these sides will be side A, or A. Okay, but that is lowercase a. So one of these sides will be lowercase a. The question is, which of those sides will be A? Would it be this one? Would it be this one? Or would it be that one? Okay, here's the way you do it. You have to understand what is the opposite. So, if I'm talking about angle A, the opposite has to be a sine. Now, angle A, the side that is opposite to A is this side over here. This is the opposite. So, BC, side BC is the opposite of angle A. Now, the way to memorize this is opposite means further apart. Of these three sides, the one that is further apart from angle A is A. Means so you really have to understand what the opposite means. So for example, let me review what I said earlier. I'm looking for the opposite of angle A. Here's angle A. Now I can look at this side. There's three sides. I can look at this side, and this will not be the opposite because opposite means further away. This is right next to the angle. This is adjacent. So it's not that side. While maybe they're talking about this side over here. Now, if I look at this side, this will not be opposite to angle A because this is right next to it. So that's not the opposite. If I look at the opposite of angle A, this will be the opposite, okay? Because it's not right next to it, it's the furthest apart. So this side right here, this will be angle A. Now, one of these sides are remaining, one of them B, side B. Now, the way you do it is, if I'm saying an angle B, okay, which one is furthest apart from angle B? Which side? Okay, which side is the opposite from angle B? Well, this one has a name already. This is not further away, this is next to it. So the one that is opposite or further away is AC. So this right here, this side will be lowercase b. That will be the side. Now, if I'm standing at C, I'm sorry, if I'm standing at angle C, so the only one left over will be C. So this side right here is C, and that is because that is the opposite side. So you have to understand what the opposite means, okay? Opposite means they're further apart from each other, okay? So for example, which angle is opposite to side B? Which angle is opposite to side B? The opposite is cannot be angle C because that's right next to it. Cannot be angle A because that's right next to B. The one that is opposite to angle side B is angle B. Okay. Now, the parts have a name right here. An isosceles triangle has legs, and the legs, when you're talking about legs, you're talking about the sides that are congruent. Okay. So this will be a leg, and this will be the leg. And the reason why they are the legs because those are the two sides that are congruent. Okay. Now, if these are legs, what is this right here called? This is called the base. Now, some of you have the idea the base means the bottom. No, the base could be at the side, could be on the top. The base, if you're talking on equal isosceles triangle, the base is a side that is not congruent. Okay. Now, If the angles have special names, there's something called the base angles. And once again, doesn't necessarily mean that if they have to be in the bottom. This is the base angle, and this is the base angle. Okay, now this angle has a very, very special name also. It's not called a base angle, it's called a vertex angle. So if you're looking at an isosceles triangle, the sides have special names. They're either legs or base. If you're looking at the angles, they're base angles or they're vertex angles. Okay, so you have to know that. So basic definition of isosceles triangle is a triangle where two of the sides are congruent and they're called legs. Okay, now for an equilateral triangle, an equilateral triangle looks like this. And what makes an equilateral triangle special is that all the sides, they're all congruent. They're all congruent. There is no base angles because all of them have the same measurement. They just called sides and they're called angles. So basically, it is measures m units. These will be m and these will be m. All the sides will be equal. Basically, this is 7. This side will be 7. This side will be 7. Okay, that is supposed to know about an equilateral triangle. And you're also supposed to know the following. Uh, we're also going to be using a lot of what they call vertical angles. And we're going to be using this over and over again here, so you need to know what vertical angles is. Basically, we're going to be using a lot of what they call the vertical angles theorem. And that one says the following. That one says all vertical angles are congruent. All of them are congruent. So, remember vertical angles that look like this. If you have two intersecting lines, okay, let me label them. This would be angle 1, angle number 2, angle number 3, and angle number 4. So basically all vertical angles are congruent. Angle 1 and angle 3 are congruent, so they're vertical, so because vertical they're congruent. And angle 2 and angle 4 are vertical angles, and because they are vertical, they are congruent. So all vertical angles, they're all congruent, okay? And the last thing we're going to be using is called the linear pair theorem. Linear pair theorem, and that says something very similar to the other one. It says basically all linear pairs are, but they're not equal, they are supplementary. And you should know supplementary means if you add them, you should get 180 degrees if you add the measurements. So, linear pair angles, they look like this. You have a straight line. That's why it's called linear pair. And you draw an angle right here. So if I call this angle 1 and angle number 2, then you know that the measurement of angle number 1 plus the measurement of angle number 2 is equal to 180. Okay, so you need to know all these facts, and new for today is the following theorems. So new, that one says the following. Okay, that one, the first thing I want to talk about is called the isosceles triangle theorem. So this is called isosceles triangle theorem. Sorry, and this one says the following. Okay, to save me in the writing, I'm not gonna write triangle. I'm just gonna put the symbol for triangle. Isosceles triangle theorem, and that theorem says the following. And that one says the following. It says if two sides of a triangle are congruent. So basically, if two sides of a triangle are congruent, that's an isosceles. So that's why we call it isosceles triangle theorem. If two sides of a triangle are similar, then the two angles opposite to the side are congruent. Okay, what's important in this theorem, you have to know what are the opposites. Remember, opposite means further away from them. So if you make a schematic, make a drawing, draw a triangle, and let's call that triangle ABC, A, B, C. And then if two sides are congruent, let's say this side is congruent to this one. So the theorem says the following. If side AB is congruent to side CB, then the opposite angles, okay? What angle is opposite to this side? Okay, you're talking about the angles. Angle C, angle A, angle B. Which one of those angles is opposite to this side? Remember, opposite means further away from this side. C is not away, it's not far away from that side because you know what? It's next to it. So it will not be B, it will not be C because they're attached to it. The one that is further away from this side is A. So angle A, that's the one that is further away from AB. Now, which is opposite to CB? I'm sorry, AB. Okay, here's AB. If you're talking about angle A, angle C, and angle B, the angle that is furthest away from this side will be angle C. So A is congruent to angle C. Okay, so if two sides are congruent, then the angles opposite to them are also congruent. So angle C would also have to be congruent to angle A. That's what the theorem says. Okay, now we have something called the converse of isosceles triangle theorem. And what converse means is whatever you say it, now say it backwards. What that means is you change the order of what you're saying. So that theorem, the converse of the isosceles triangle theorem says the following. Okay, uh, this would trade places with this. Okay, so basically what I'm gonna say, not if two sides of one triangle are congruent, what I'm gonna say is the following. If two angles of a triangle are congruent, then the sides opposite to these angles are congruent. So basically, in the drawing, drawing a triangle, call it ABC. A, B, C. And by the way, this is known as a hypothesis. Anything in here is known as a hypothesis. So you're assuming that's true. So if two angles are congruent, let's say that this angle is congruent to this angle, then the sides are opposite are also congruent. So I'm going to say the following. If angle A is congruent to angle C, then, okay, here's angle A. These sides AB, CB, and BA, which of these sides will be opposite to angle A? Remember, opposite means further away. AC is not the opposite, that's right next to it, okay? AB is not the opposite because that's right next to the angle. The side that is opposite to angle A is this side, CB. So side CB would have to be congruent to another side, okay? Now, what is the side opposite to angle C? Here's angle C. These sides will not be opposite because they're right next to it. The one that is opposite is further away from it. So the side AB. A, B. Okay? So basically, if you have congruent angles, the sides opposite to them would also be congruent. Would also be congruent. Okay? So let me do a problem. I have three examples for you. And they go from easy to more and more and more complicated. So problem number one is find the value of x, and they gave me this problem. So I didn't take the picture. Let me take a picture. Okay, so they gave me this problem. Let's go to this example number one. And the question is find x. Once you find x, you're done. You're done with the problem already. Okay. So what you need to know is to know the following. They gave me all these angles are congruent. If the angles are congruent, then the side opposite to them are also congruent. So here's what happens. The side that is opposite to this angle will be, the side that is opposite to this angle is 6. So 6 equals congruent. The side that is opposite to this angle will be this side. So this will also be congruent. And the side that is opposite to this angle will be this side. So all of these will have the same measurement. So this 6, this will be 6, and this will be 6. So my answer for this particular problem is right here. My x is equal to 6. Now, the theorem that I told you about is the isosceles triangle theorem, but it also applies to equiangular, same angle. So if the angles are equal, the sides opposite, then would also be congruent. So x equal to 6, that is the answer for example number 1. Example number 2 was in question, find the value of x, and they gave me a different drawing. So problem number 2 is the following. They giving me this drawing. Okay, and what I'm gonna do is I'm going to focus on only this triangle, and here's what I'm gonna do. These two sides are congruent, so the angles opposite to them are also congruent. So these three angles, two of them should be congruent. Now, the angle that is opposite to this side will be this angle because that is further apart from that one. Now, the angle that is opposite to this side will not be this one because that's right next to it. The one that is further away from that one will be this angle. So what that's telling me is that this angle is equal to this angle. Okay. Now, on this triangle, I know that if I focus on only this triangle, if I use the angle sum theorem, if you add all the angles, you should get 180. One of the angles is 44. The other angle is, I don't know, let's call it, can I use X? Let me call it A, and let's call this A. So A plus A is equal to 180. So the equation step number one, eliminate parentheses, fractions, or decimals. I don't have any of them. Number two is combine like terms. On the left side, these two can be combined, so you're gonna have 44 plus 2A is equal to 150. Step number three, I'm sorry, 180. Sorry about the mistake. Now, number three is separate variables and constants. Variable means letters. I would like to have the letter on the left because it's already on the left. Constant on the right. Variable means letters. These two, the one that doesn't have a letter will be 44, so this would be minus 44, minus 44. These will cancel, so the answer is 2A is equal to 0 minus 4, you can't, you need to borrow, that should be a 7. Now it's a 10, 10 minus 4 will be 6, 7 minus 4 will be 3, that is 136. Now get the A by itself, so divide by 2, divide by 2, these will cancel, so A is equal to 2 divided by 136, 2 divided by 136. 2 goes in 13 6 times. 6 times 2 will be 12. 13 minus 12 will give you 1, bring that to 6. And then 2 times 8 will give you 16. And 16 minus 16 will give you 0. So this will be 68. So now I know this is 68. So this will also be 68. This is 68 and this is 68. Now, if you only look at this right here, these are vertical angles. So this is 68. This will be 68. Okay, this is 68 because these two vertical angles, this would also be 68. Now, they gave me two congruent sides, so therefore the angles opposite are also congruent. So the side that is opposite to this one will be this angle right here. The angle that is opposite to this side will be this one, 68. Now, what angle is opposite, further away from this one? These will be congruent. So this 68, this will be 68. So there's my answer. My answer is X is equal to 68. And that was the question, what is the value of X? I found it. That's my work. Okay, so as you can see, we're using the vertical angles. I'm using the opposite angles or the opposite side, a lot of them. I'm also using the angle of sum principle. If you add all the angles, you should be equal to 180. And I'm also using a lot of vertical angles. Vertical angles will be congruent. Last example, and then you're ready for the homework. Last example will be example number 3. This is number 3, and once again, find the value of X. So there is example number 3. So what I'm gonna do is the following. I'm gonna start with this triangle right here. My focus is gonna be this triangle right here. That's what I'm focusing right now. Now, that tells me the following. If two of the sides are congruent, then the angles opposite to these sides will also be congruent. The angle that is opposite to this side is not this one, that's because they're right next to each other, right next to the side. The ones that are opposite is this right here. So this angle, now what angle is opposite to this side? The angle opposite will be this side. So these two are congruent. So therefore, if that's 62, these will be 62. Now, if you add all the angles, you get 180. So if I do 62 plus 62, now I don't know this one. I don't see any of the x's. Then I put x right here. So this will be x. That should equal to 180. So for x, get the x by itself. 2 plus 2 is 4, and 6 plus 6 is 12. Plus x is equal to 180. Um, Minus 124 minus 124. These will cancel. So you have x is equal to 0 minus 4 can do it borrow. This should be a 7 and this should be a 10. 10 minus 4 will give you 6. 7 minus 2 will give you 5. And 1 minus 1 will give you 0. So x is 56. So this one is 56. Now, if you look right here, this is a linear pair, which means this plus this should give me 180. So what I'm going to do is do the following. 56 plus the other angle. I cannot use 6 anymore. Let me use y. You can use whatever letter you want. Is equal to 180. Okay. All linear pairs, they're supplementary. That means you add them, you get 180. Get the y by itself. This will be minus 56 minus 56. These will cancel. So you have y is equal to, borrow the 0 minus 6, you can do it, borrow from the 8, that becomes 7, this becomes 10. 10 minus 6 will give you 4. 7 minus 5 will give you 2. And that's 1. So y is 124. So this is 124. Now, they're not asking for x or y, they're asking for this angle. Okay. Now my focus should be this triangle right here. My focus now is this triangle. That is my focus. So one of the things to notice is the following. Two of the sides are congruent. So if the two sides are congruent, then there's going to be two angles that are congruent. The angle that is opposite to this side is not this angle. That angle is this one. So this angle will be opposite to whom? What angle is opposite to this side? The one that is opposite to this side will be this one. Now, I can use this another letter over here, but one of the things to notice is this angle and this angle, they're vertical angles. And vertical angles are congruent. So this is angle 2, this is angle number 2. So I'm going to do the following. If you use the angle sum principle, if you add all these angles, you should get 180. So one of them is 124. Then angle 2 is, they tell me angle 2 is x plus 35. Now this angle 2, this is also angle number 2. And angle number 2 is x plus 35. And that should be equal to 180. If you add all these angles, this plus this plus this is equal to 180. So for x, and that'll be your answer. Okay, x plus x is be 2x. 124 plus 35 plus 35. Here's how you do it. 5 plus 5 will give you 10. Plus 4 will give you 14. 4. Carry your 1. 3 plus 3 is 6. Plus 2 is 8. Plus 1 is 9. So this will be 194. And that's equal to 180. Now minus 194 minus 194. These will cancel, so you have 2x is equal to negative 14. Get the x by itself, divide by 2, divide by 2. The 2's cancel, so you have x is equal to negative 7. And I'm sorry I didn't see this. They have an x. Okay. So next time I do this, I when I use x in here, I'll use a different letter, any letter except for x. So my answer for this problem is x is equal to negative 7. Okay. Now some of you might be saying, well, none of these look like the problem that I'm doing. I can do it. I spend years doing problems, and every problem will be different. Okay. The problems are different, but the idea is the same. You're gonna use the angle sum principle. That means if you add all the angles, you're gonna get 180. You're gonna use the vertical angles theorem. You're gonna use the linear pair theorem. All vertical angles are congruent. Linear pair means all linear pairs are supplementary. And you're gonna be using the isosceles triangle theorem. If two sides are congruent, then two angles will be congruent. Okay. Try the homework and good luck with the rest of the work.